Hello everyone, my name is Mercedes. I am from ISMT College affiliated with University of Sunderland, BSc Honors Computer System Engineering student, registration number 220124009. Today we are going to talk about the intelligent prototype development, dataset and data. So first of all, on the Jupyter notebook page we have assignment, credit card, for our phone data, Python code, and we have the credit card 2020, that's CSP data. So let's go to the assignment. I have already opened it here. You can see credit card for data direction data sheet is 2023. See, a table of counting on the data input, employment inspection, data cleaning, exploratory data analysis, model input, development and validation. So first of all, it's important file for is to run the code which is necessary for, you can see, data manipulation, visualization, exploratory data analysis, and different other data are being imported. So data input and inspection, here you can see we have input the credit card 2020 CSP data so that we can import the file from that to the Python. So you can see here you have ID number for the credit card and the V1 to V3 V4 5 up to the 28. You can see these are the microfunctions or the sum of the function, mini function of the credit card, which will be background, amount and a class. So about that we are going to talk later about the class y is 1, 0 and 1. So next let's go to the display information and the structure. So first of all, data credit card information is which in the 0 to 30 and the ID is so that B1 to B28 and amount and the null will show the sum of the data, D type data integer, and the float is for 1 to 29 and the for the class is integer. Let's go to data cleaning. So first of all, credit card clean, if check if this data results clean now, then it will data drop unnecessary and it will target the class and comprehend it up. Now let's go to the missing data check. In that it will count the total number. You can see total number of missing value is 0, so we don't have miss anything. Duplicate entry checking, so it will inspect the whatever there is duplicate entry. You can see that here has two entry which have this under the function of the B2, B1 to B28, and also amount and the class are the same. Similar data are being input, which so it is duplicate, and this will function will drop one of the duplicate data. Now let's go to the outline detection. So first of all, this will outline the data which you have given and here comprehend them. After that, a dictionary will create it in this function and it will extract them and show the outline per factor. You can see here features and the number outline. You can see that 7 and the 20 B8 is 9385. Likewise with the decreasing order of this, and you can see total in the 0 V1 is 30, so the amount 28 and amount is 0. So it's going to show the outline from highest to the lowest. After now on this outline will be defined and count occurrence will be occur of the outlines. So create a data frame and store frequency count at the p-value, and create a bar chart for the number of transactions per outline, event count, and we show that the fraud and non-fraud. So fraud value which is 57% and 63%, and it show also in the division as it's for we have seen in the above function here. So you can see the frequency of transaction and the number of outline. It will show the percentage, and Now let's go to data random shift and training and test. So it will going to split the data and test the subset exploratory data analysis. So display the descriptive statistics of features. So it is going to show the features. Some of them you can see version 1 to 28 and amount are showing. Will the count are given total of count and the means their STD minimum 25%, 50%, and maximum. This amount are showing here. You can also see the amount of this total here. And now we are checking the total amount of credit card transaction covered in the training data set. 2,740,286,824.30, and the data clean target described as a class, and the count is 227,451, unique is 2220, and frequency only 113,753. So let's go to, and the count occurrence unique value target is class 0, and the is value is 113,753. So make unravel plots. So it's going to show us making the QQ plot and calculate normal static. So here you can see calculate the normal static and see it will handle the process and it will generate a normal Q for which we are going to see. Next, let's see. You can see that quantum quality and the version 1 V1 and the quantum quality. You can just check the V1, V2, V3. So each of the carrier function we can check there. Data some are going straight, some are going out of line, and so the different value according to the data we possess till 28, and the last one will be amount. You can see the data quantum amount and the theoretical quantum amount. So similar to that, generated box plot is being developed, for which will show the box plot of the feature similar to the above. This one also shows the V1, V2, V3. You can see the different types of box plot is being displayed here from V1 to 3 to 28, and to also the amount. Now let's check the collinearity among the features. To calculate the collateral matrix for features means it will use by the heat matrix. So you can see that collateral matrix of all the feature and the coefficient of the collateral 0, 2, 0.2, 0.4, 0.6, 0.8, and 1.1. You can see V1, 2, 3, 4, 5 to 28 and amount. Similar to that, you can also check here 1 to 28 and amount. You can see that it's thinking about different values when shown by different number, and the different color is representing from cold to hot. Similar, you can see this region is cold while this region is hot. You can see that this vertical line is maximum coolant. Now let's go to calculate and the variable impedance factor VIF for the each feature. So in this feature we are going to we know V1, V2 to V8 are the features and amount. So VIF will give them the point based on their transaction data. You can see that V17 is 6.4, which later goes on decreasing order slowly to amount is 1.0. V26 1.1. So let's go to the evaluation calculator between features and target. You can see here we have created the bilateral titles of varied plots. So similar to the QQ plot and the blocks box, we also see that the plot also show the B1, B2, B3 in different data are similar to above from 1 to 28 in amount. It shows the data being compressed here. So let's go to the principal component analysis. We have created the standard plot stand and the feed transformation, and we have visual plot, screen plot with the axis, and you can see that screen plot explain the variable of ratio with the explanation variation ratio to principal component. This also the complete expression variation ratio to principal component, which goes on the increasing order while the bar chart also show the. Now visual PCM pilot. This related over features. This will show the corresponding relation to the each feature of the credit card. You can see 4, 2, 20, 23, 20, 11, 1, and the amount is being shown in the direction by the display of the arrow with the principal component and the principal component 2. Plot scatter plot transaction project for the first two principal component. Scattering point using the C1. This shows the fraud and the non-fraud point where you can see they are getting the cluster together. Similarly, you can see the non-fraud is being split little bit wider, but fraud on the other side see being the cluster together with the principal component first and the principal component second. Cluster analysis. So we are going to specific number of cluster is to the fraud and non-fraud. So which will use the k-means with the specific number of cluster and the other parameter create the confused matrix display. So this confused matrix display show the true level and the prediction level of the fraud, non-fraud, being the 50 and the fraud being the 11.65 and 0.1 and 3.8. Prediction value also you can see check there. Now let's go to plot scatter plot transaction project to first definition. Here you can see negative and the false similar to the fraud and non-fraud cluster. You can also see them being clustered together similar to the above. Model development and validation feature scale. So this is going to call the standard scale for the feature scaling, and on the modeling develop and training we have list the classification of the specific parameter. These are the parameter of the, you can see algorithm, k-neighbors classification, logistic regression, ESGD classifying, decision tree, extra tree, classify, NB. So you can see that these are the algorithm or classification which are being used by the code for the verification and the detection and for the tricks for the credit fraud. And with the data frame from the display model we are going to use them as a variable and show the result of the training. So you can see here we have the result classifier, extra tree classifier, k-neighbor classifier, decision tree, logistic regression, SDG classifier, and so training accuracies which are the extra tree are the highest accuracy, precision is the 0.99604 and 804, while training recall is 1. But k-neighbor also has similar but just a point small. A10 Wi-Fi also 999 and validation accuracy 999 and validation precision, validity call, validation F1, and the computing cost is 487.9809 while the k-neighbor 375. This shows that the extra TD is the most suitable for our model to use for the prediction of the credit card fraud, which as the 99.9% accuracy. Model validation. So we have select the model, that is this. We have select the model based on the. So you can see here we have made the confusion matrix. You can also see fraud and non-fraud, and it show the true level and the prediction level. Model testing. So here we have testing the model, which we have by model validation, that by using the confirm again, and by using them we have seen that accuracy score for test is 99% and the precise score 0.99, also 99%, recall also 0.997, also 99, and the FN also 99%. So you can see the true level and the prediction level of the fraud, non-fraud, fraud, non-fraud, and fraud based on the data shown here. So here you can see the credit card raw rate, which show the sum of the record. As you see, it has the 00 and the 0 for the classes, so it show the non-fraud. But during what if show the classes 1, then it means it is on the fraud list. It is on the credit card fraud list. So the credit card raw is the same, is 586,630 and 31 is the column from where your logistic is. You can see the confirmatory validation set, the data different with the accuracy of the confirmatory test set also shown here with the accuracy of 96%. Here you can see the picture of that validation set confirm matrix and the test set confirm matrix. Thank you.